Error in division means in earlier video we discussed about the combination of error, that is error in addition, error in subtraction and error in a product. Means whenever the sum of the values or quantities are taken, when they added, then how do we find out the error and what is the maximum possible error also we discussed, and we derived an equation for that also. Now we are going to discuss about error in division or quotient. So here same as we are taking that, let take a z is equal to x by y. X by y be the equation, that is a division equation. We know that in the error we can write that z term as a z plus delta z, because of in x term is a, that is a plus or minus delta x, and in y term that is delta plus or minus delta by be the absolute errors which can be taken. These are the absolute errors in x quantity and y quantity. So by to know the error in division in this equation, then we can get that z plus delta z, which is equal to x plus or minus delta x by y plus or minus delta y. X plus or minus delta x by y plus or minus delta y we can write. Here the x plus delta x with the equation whenever we take in that x plus delta y x and the y plus delta y plus or minus delta y be the equation for the absolute error in a y term. So by taking z plus delta z, which is equal to, I am taking x taking outside from the equation, then we can get that 1 plus or minus delta x by x, 1 plus delta x by x by, in this term y taken outside, then we can get that plus or minus delta y by y. So if we write this equation, then we can get that z plus or minus delta z plus z is equal to x by y of, we can write that 1 plus or minus delta x by x, and as well as 1 plus or minus delta y by y, we can write that is 1 plus or minus delta y by y inverse. So then also we can write that 1 by 1 plus or minus delta y it comes. Then if in case this, whenever the inverse which has taken that, then this equation also can be written as a x by y of 1 plus or minus delta x by x. Here we can write that this 1 plus or minus y can be written whenever the removal of the inverse, then 1 minus or plus delta y by y. So here we can write another thing also, z plus delta z, which is equal to x by y 1 plus or minus delta x by x into 1 minus or plus delta y by y. Because of we are removal of the inverse, whenever it is multiplied inside, then we can get that 1 plus or minus becomes 1 minus or plus delta y by y. So if we multiply this one, if multiplied both, then we know that the x by y which is equal to this x by y which is equal to z from the initial equation, x plus y is equal to z. So from that equation we can write that z plus delta z, which is equal to z into 1 plus or minus delta x by x into 1 minus or plus delta y by y. This is the equation. Then whenever the z is also taken common this from this equation, z of 1 plus delta z by z is equal to z into 1 plus or minus delta x by x into 1 minus or plus delta y by y. We can get this equation. So here once again listen, when from this equation we are z is equal to x by y is the general equation we have taken to know the error in division. So we know that z is, whenever the error, to find out the error we are adding the error either in minimum error, which is absolute error, which can be taken in x term is plus or minus delta x, and in y absolute error is plus or minus delta y. So that's why we are adding that one, then we can get this equation. From this equation whenever the x is taken to outside, then we can get x of 1 plus or minus delta x by x. If we multiply this x inside, then we can get the same x plus or minus delta x. Here is also y taken outside, then y of 1 plus or minus delta y by y, and whenever we multiply this y inside, then we can get the same equation. So this 1 plus or minus y can be written as 1 plus or minus y, delta y by y can be written as 1 plus or minus delta y by y inverse, 1 plus or minus delta y by y inverse. By multiplying the inverse into this, then we can get that the same term will remain same, and this term becomes 1 minus or plus delta y by y. From this equation we are multiplying both equation. Before that, z is taken outside from the z plus delta z, then also same we can get that, then z get cancelled, get cancelled, then we can get 1 plus delta z by z, which is equal to, if we multiplied both, then here 1 into 1 1, and minus or plus delta y by y, and plus or minus delta x by x into 1 plus or minus delta x by x. Here whenever which can be written this one, that is a plus or minus delta x by x into delta y by y. But we know that the two terms, the delta x by x and delta y by y values are very small. Delta x by x and delta y by y are very small. Very small. We can neglect it. So here, by removal of the plus 1 and plus 1, this both will get cancelled on both sides. Then from that equation we can get a delta z by z, which is equal to, here that is a plus or minus which can be taken outside, then we can write that delta x by x plus delta y by y. We know that whenever we take the values, it must be absolute error must be in positive. So that's why delta z by z is equal to plus or minus delta x by x plus delta y by y. In this case of, we can write that here the division means the error in division or the error in coefficient can be written as the maximum fractional error. The maximum fractional error in the quotient is that equal to the sum of their individual fractional errors, the sum of their individual fractional error. Means if we want to know the percentage of the absolute error, we can write that here, that is delta z by z into 100, which is equal to plus or minus delta x by x plus delta y by y into 100. So whenever the 100 also multiplied that, we can write this equation, same as equation can be written as a delta z by z into 100, which is equal to plus or minus delta x by x into 100 plus or minus delta y by y into 100. We can write like this also. So from whenever taken this side, then here is the equation to write the error in division or coefficient. Once again, error in division or coefficient, we can write that how to find out the error in division or coefficient by using this formula. Then z is equal to x by y. Z is equal to x by y with the equation which has taken. In the x, the absolute error is plus or minus delta x. The absolute error in y is plus or minus delta y. So in that case, in the delta is that is a delta z with the absolute error. So whenever we want to know the error in division, then z plus delta z, which is equal to x plus or minus delta x be the error in x term, and y plus or minus delta y be the which is the absolute error which can be taken in y, the exact value, because of whenever we added or subtracted the sum of the error value, then the true value which comes. So by taking the x outside, then we can get that 1 plus or minus delta x by x, and from the y 1 plus or minus delta y by y. This is in denominator, so whenever it taken to the numerator, it will become inverse. So that's why 1 plus or minus delta y by y inverse. This inverse, whenever it is multiplied inside, then we can get that the internal signs are changed, that is a plus or minus becomes minus or plus. so that 1 minus r plus delta y, the remaining terms will be same. Here x by y which is equal to z, we have that from the initial equation, so that's why we are writing that z plus delta z which is equal to z, and from the remains values will be remain same. So whenever we multiply this equation by cancelling the both, whenever the z is also taken outside, then we can get that 1 plus delta z by z, then total 2z on both sides will be get cancelled. So here the 1 plus r minus delta x by x into 1 plus minus r plus delta y by y both will be multiplied. Then we can get that is 1 plus delta z by z is equal to 1 minus r plus, because of 1 into 1 into minus r plus delta y by y is delta y by y, plus r minus delta x into 1 is plus r minus delta x by x, and plus or minus delta x by x into delta y by y becomes that is delta x by x into delta y by y, which can comes. Then here we know that delta x by x value and delta y by value is very small, both our values are very small, so that's why we can neglect it whenever they both values are multiplied, and we can neglect it. So here the remaining value, the 1 get cancelled, then remaining value is delta z by z is equal to plus or minus, that is delta x by x plus delta y by y, which can comes. This is the maximum fractional error. This is called maximum fractional error. Maximum fractional error. Fractional error. Error in a quotient. In coefficient or division value, whenever which is equal to the sum of their individual fractional errors. So sum of their individual fractional errors, this is the sum of their individual fractional errors, which can be, we can get the sum of this. So to know the percentage in error, that is delta z by z, and whenever we multiply it with the 100, then we can get the percentage. So delta z by z into 100, which is equal to plus or minus delta x by x plus delta y by y into 100. If the 100 is multiplied inside also, we can get the same thing. This is about the error in a quotient or error in a division. And error in power of a quantity. Error in power of a quantity also same as which we are taking that the general expression we are taking that let z is equal to x power n. This is to know the power of a quantity. If in case of in the terms of x quantity will be taken many things by after this knowing this, then we will discuss about one example, then we can get clarify all the doubts about how to find out the errors on division or error in subtraction, product, and as well as error in addition. So later the z is equal to x power n. We know that then the x, the absolute error is plus or minus delta x, and as well as in z we can write that there is delta z with the absolute error. By substituting this one, then we can get z plus delta z, which is equal to, in x we are writing that x plus or minus delta x power n, x plus delta x plus or minus delta x power n. So whenever the x is taken to outside, then we can get that z plus delta z, which is equal to x power n into 1 plus or minus delta x by x whole power n. Whole power n means if we multiply the same thing, then we can get the same here. So here whenever the x is taken, x is power n is there, so that's why we are writing that x power n in the outside, then we can get that 1 plus or minus delta x by x. At the same time we can get that. So but we know that here z is equal to x power n. So from that, in this place instead of x power n we are writing the z, then z is plus delta z, which is equal to z into 1 plus or minus delta x by x power n. So here we are writing that is z taken to this side, then we can get that z plus delta z by z, which is equal to, from the binomial theorem we can write that 1 plus x power n is equal to 1 plus or minus nx. Whenever we take that is 1 plus or minus x power n from the binomial theorem, which can be written as 1 plus or minus nx. From this formula we are writing that from the binomial formula, then here 1 plus or minus n into delta x by x, n into delta x by x. Here we can write that z plus delta z by z can be written as 1 plus delta z by z. By cancelling, by dividing this denominator to both of them, then we can get the z can cancelled, and remaining term will be 1 plus delta z by z. that is equal to 1 plus or minus n into delta x by x. Here the 1 and 1 get cancelled, the remaining term will be, that is maximum possible error delta z by z, which is equal to plus or minus n into delta x by x. This term will be given that to know the error in power of a quantity, means if in case of, if we get that is x square, then to know the power x square, to know the power error in division, then we can get that is 2 into delta x by x will be the error. We can write that like this, same as to know the percentage error, to know the percentage error, that is delta z by z into 100, which is equal to plus or minus n into delta x by x into 100. In this, like this, we can write that percentile error also. Here also we can write that same thing as whenever the total, the fractional error in the quantity with n powers is the n times of the fractional error in that quantity. N times, here we have that the n times the fractional error, n times of the fractional error of that quantity is called the error in power of a quantity. Means when the fractional error is to know in a power of a quantity for n times, means which we have taken that n times, we have taken z is equal to x power n times, so that the error in power of a quantity for n times, which is equal to the sum of the here we can retain that the sum of the n powers n times the power of the fractional error of that quantity. Here is the n times the fractional error of that quantity, delta x by x be the fractional error of that quantity. So this is about to know the fractional error of division, and at the same time the error in power of a quantity. This is about to know the errors.